Hi, welcome back to an introduction to audio programming, a presentation of the 1X Developer Podcast. I'm Brendan,
And I'm Colin.
and this is a segment we're calling Make Mine a Double Precision Floating Point Value. Albert Einstein may have said, but probably didn't say, if you can't explain it to a 6-year-old, you don't understand it yourself. Here at the podcast, we say, if you can't explain it after you've had a six-pack, you probably don't understand it yourself. So here we are talking about audio programming. Uh, this is part 6 of a series of videos. So if you haven't checked out the previous ones, check out the previous ones. In this episode, we're going to talk about, we're going to actually look at some code. That's like, you know, the whole point of all this. We've done a whole lot of prep work, and now we're going to actually look at some code. So
Juice.
comes with this program called the Producer, which is a program that produces audio
That's pretty cool.
produces
Yeah.
juice applications. So I've used that. It's pretty self-explanatory once you get in there. I was going to kind of demo creating a program, but when you get in, if you download Juice and you open the Producer, it'll be pretty self-explanatory about what you want to do. The one big question there, I think that's important to look at is it has one section for application and one section for plugin, and that's kind of what we were talking about earlier about like standalone applications versus plugins that are going to be instantiated from within your DAW or something like that, right? That's really common in the audio world, is to have um, plugins that are instantiated from a DAW, and then the DAW is basically the host, and the plugin is kind of the guest, I guess. But in those, I think the important thing, the programs have a slightly different structure, and we'll take a look at those here. But the the heart of the application, this kind of like callback, this audio callback function, kind of remains the same. So I generated kind of just a basic standalone application here, and this is the main CPP function. So this actually has your main function somewhere in there. So you can see that you have a class for, I called it test audio application. It inherits from Juice application, and it has some basic info that this comes directly from the producer, the name and the version, things like that. You have a handful of functions here. You have initialize, shut down. These are
Initialized
all.
with an S?
He's British.
Is that an
Colors,
English thing?
yeah.
I didn't know they spelled initialized differently.
Also, all the color stuff, it has a U in it.
U. Yeah.
Yeah.
I mean, I knew about that. That's a common thing. But wow. Anyway.
Yeah. Initialize with an S. Yeah, be sure to note that if you're in the US. But the main point here is that this main CPP function, you probably should never need to touch it. Its only job is to instantiate this main. Where is it? Main. Yeah. So you have this main component. This is all stuff that, again, that's generated by the producer. So it generated a main component, and then this main CPP included that main component and made main component a child of the main application, basically.
Okay.
So, all that is just to say that you probably won't ever need to touch main CPP. You probably shouldn't ever need to touch it. So,
Okay.
main component, main component.h here, that has 3 main functions that we care about in this case. Prepare to play.
This is a C++ thing, right? The .h, that's like a header file or something?
Yes. Sorry. Yes, this is all C++. So you have a header file and a CPP file. The header file contains the declaration. It's just the function declarations here.
Okay.
and then the CPP file includes the actual implementation of the functions.
Okay.
So you can kind of look at the .h file to get an outline of what functions are declared, but the real meat of it happens in the CPP file.
Cool.
So there's basically three main functions. So this is our main component. It inherits from the Juice audio app component, and the audio app component contains both like the UI stuff and the audio stuff. So these first three functions are related to the audio stuff. Prepare to play, get next audio block, release resources. Those are audio functions. Prepare to play is called when the program starts, but also anytime the user changes their their sample rate or their samples per block.
Okay.
Again, remember those are like things that are decided by the user. So you get those values as calls to this function, and your audio application should be able to respond to those if the user happens to like change them midstream. They don't change constantly, right? They don't change all the time, but you should be prepared to respond if they do change. Release resources similarly gets called when your program ends or when the user changes these values. It'll call release resources and then prepare to play with the new values. But get next audio block is really like, that's what we're talking about here. That's the heart of the audio application. So so basically this basic thing that I generated from the producer just says for get next audio block, it just says, you have one argument here, which is buffer to fill. And we've kind of talked about that in previous videos. That's the chunk of memory that you're supposed to fill with your audio data before the next time this function is called. And all this function does is just clear it. It just sets it all to 0.
Yep.
So easy peasy.
Cool.
This is a basic. This test audio plugin is just exactly the same thing. It's just the most basic plugin you can generate from the producer, except it's a plugin. It's instead of a standalone application. The structure is a little bit different here. A lot of it has to do with, again, the fact, like I mentioned earlier, there's no entry point for the operating system. This is like your DAW will be instantiating this plugin, right? So like one of the things is it might run, it will often run without a UI. It will run kind of in the background,
So maybe you're about to get to it, but when I'm developing a plugin, is there like a standard audio workstation plugin? Like can I run my plugin in like any DAW that I use or anything that supports Juice, or like what's going on there?
Oh, yeah. Great question. Juice allows you to select which, okay. So there are different plugin formats. There are a handful of them. Juice allows you to select which formats you create your plugin in.
Okay.
Let's see here. Yeah, like this one that I made that was just the basics. Trying to see here, but yeah, I mean the long and the short of it is that the basic producer plugin option will create an AU and a VST. Those are two different.
Okay, yeah.
Those are two different
right.
plugin formats, and it's up to the DAW to decide which plugin formats it accepts.
I think most of them support VSTs.
I think so.
Like most of the big ones.
Yeah. So VSTs are pretty across the board, and I think at this point, VST version 3, there was a period there where that was kind of dicey, but like I think most DAWs support VST3 these days. And then AU is kind of that's a Mac specific kind of thing. I don't know if any DAWs outside of the Mac world support that. Pro Tools, I think, has its own format called AAX. And then I'm looking at the Producer here, and it has a something called an ARA format, which is like kind of augmenting the basic audio plugin with ARA functionality. That's a new thing for me. I'm not familiar with that.
Okay.
But the short answer is that your Juice plugin, when you're using the Producer, your plugin will output to multiple plugin formats, and then it's up to your DAW to support those formats. And so the other thing about plugin formats is that there's a little more info going on in the header here. For example, like accepts MIDI, produces MIDI. Your DAW might be able to filter plugins based on like, do they accept MIDI format? Do they accept MIDI information? Do they produce MIDI information? That kind of thing. So there's a little more that you have to specify here in order to like get your plugin to register with DAWs and stuff like that. But the meat of it is that your audio processing code is very much separate from your UI code when you're doing a plugin. Trying to think how to say that. It's when you're writing a standalone plugin, they're kind of like in the same file. Does that make sense?
Yeah.
And so, but again, this is just like the absolute most basic. The functions are named differently, but the the functionality is exactly the same. Prepare to play is run when your plugin starts, or when somebody changes the sample rate. Release resources is when the plugin closes, or it's or when the sample rate changes. Process block is kind of that's the meat.
So what kind of stuff are we making plugins for?
Well, like one I'm going to show you is like generating a sine wave. That's just like a basic.
It's very simple, yeah.
Yeah, that's like I think that's a really good place to start. So let me see if I can.
But like I mean, a plugin could be it could make sounds, or it could be like a filter, or like an EQ, or any of that.
Yep, exactly. So yeah, in an earlier video we kind of talked about that's kind of like the wide open horizon of an audio plugin. You get this chunk of memory, it's your job to fill it. You can fill it by generating data, or you can fill it by taking data that's already in the buffer, processing it, and then putting it back into the buffer, right? So what you put into the buffer may or may not be based on what was in the buffer beforehand. So that's kind of the difference between a synthesizer and like an effects plugin, is just that, one of them relies on the input and one of them doesn't.
Cool.
So here's an example of this sine. This is just generating a sine wave at a given frequency. I think this was really like, I know this seems basic, but this is really, really eye-opening for me. Like, this is as simple as it gets. This is your the most basic audio plugin you can write. Is like generating a sine wave at a given frequency.
Little theremin action.
Yeah, exactly.
So how are you running this right now?
Usually what happens is, like for these tutorials, you download a tutorial and you can put it in your, you'll get a juice file included with that. You open the juice file, it opens in the Producer, and then you click this button to open it in your preferred IDE. So that could be, Mac, Windows, Linux. But you open it, it'll open in Xcode. And then from there, that's where you can run it.
Okay. Cool. So it's almost like we have a standalone application of basically nothing that we can use to like run our plugin.
Yeah, this one is written as a standalone plugin, so there's as a standalone application, so there's no plugin functionality going.
Oh, okay.
I'll show you one of the plugin ones though. That works exactly as you're describing. So, this is a plugin, and when you run this one, you do get it's running inside of its own like host, basically.
Yeah.
It's like a dummy DAW almost. You can kind of see that like these buttons aren't really, this isn't normal Mac OS stuff.
Yeah.
So, and then it has some options here for like configuring audio devices and stuff like that. So, yes, you're right. No, if you're writing a plugin, then it opens and it's kind of like a dummy host.
Yeah, cool. Okay.
But one of the things I think it's important to wrap your head around in this, in that sine synth tutorial that we were just looking at, is that there's this idea that like this audio callback runs on a schedule. How many times does that audio callback need to run in order to produce a complete sine wave? It's like there's no way to tell that just computationally. That depends on the frequency, the sampling rate that the user has decided, the number of samples per block the user has decided. So you really have to, like, on every time the audio callback runs, you really have to store kind of state about like where were we in what we were generating. And I think that this sine synth tutorial is really like a good place to start with this. This really, for me, it was really eye-opening. And but you can kind of see here, I mean, you get a pointer to the left channel, get a pointer to the right channel, and then you kind of just do a for loop over all the samples, and you generate a sine wave at the given angle times a level, and then that's what you put into the sample.
Yeah, that's cool. It's so cool that you're just like making sound from just code, basically.
Yeah. I don't know anything cooler, right? Yeah. It's kind of incredible that it all comes down to that in the end. It's all just about that's why the trigonometry stuff, like I kind of debated whether or not to even leave that in this presentation, but it's like I think it's really important to understand that, because a lot of times it does come down to that. It comes down to generating sine waves over time. Yeah. I went way too quickly here and glossed over some important points in the code that I wanted to draw attention to. The first was this angle delta variable. So you can see that within the audio callback function, within the for loop, we are incrementing current angle by angle delta. So current angle is recording, where we're at currently in the sine wave. That's the angle that we're passing in. And then on every iteration of the for loop, we're incrementing that angle by angle delta. So angle delta is the change in between every sample where we're, that we want the angle to change by. The important point that I wanted to note there is that we're calculating angle delta within the prepare to play function. So if you remember from earlier in the presentation, prepare to play is called when your program starts, but also anytime the user changes the sampling frequency or the block size. And it gets called with the new values for the sampling frequency and block size. And using those values, we can calculate how much the angle needs to change on every call, right? But I just wanted to mention it's really important to note we only do that one time. That saves us from doing the calculation within the audio callback every time. So we calculate the angle delta anytime the sampling rate changes, and then we just increment that within the audio callback, and that saves us a lot of processing. We don't have to recalculate that angle delta because it's dependent on the sample frequency, and so we only need to do that if the sampling frequency changes. And within your audio callback, you can trust that that hasn't changed. The other thing I didn't explain, it's pretty simple, but this multiplying by just a float value to adjust the level, multiplying an audio signal changes its amplitude and therefore its volume. So here you can see that we just multiply by a constant 0.125 for the level. That reduces the volume because it's less than 1, right? So if previously your audio signal had maximum value of 1 and a minimum value of -1, multiplying by 0.125 means the maximum value is now 0.125. Multiplying by values less than 1.0 reduces the volume. Multiplying by values more than 1.0 will increase the volume. But just be aware of everything that we talked about with clipping there. You don't want to multiply your values so much that you start clipping and losing information. Anyway, there wasn't much more. We're not going to get too much more into examples of this stuff, but Juice has some really good tutorials. There are plenty of good tutorials online, but hopefully this gets you to a point where you can look at an example like this and kind of like understand what they're even talking about. Because that was the problem I had when I first started this stuff. I would look at a sample like this and be like, I don't even know what the hell this is. What is an angle? What is it like? I understand what digital audio is, but like, what are we talking about with samples and stuff like that? I really hope that by the time you get to the end of this, you can look at like an example code like this, understand that this for loop is cycling over all of the samples in the left channel, in the right channel, and that this is how your job is to fill the buffer with the audio data that you want to be there when the function's done running, and that you need to be done with your function before the next call.
Yeah, very cool.
And I think that's it.
All right. I learned a lot. I hope you guys did too. Thanks, everybody.
See ya.
1x Developer Podcast.
Hey, everybody. This is Colin. First and foremost, I want to thank you all for listening to this episode of the 1x Developer Podcast, and let you know that if you have any questions, comments, or if you just want to tell us about your day, you can reach us at X, formerly known as Twitter, at 1x Developer Podcast. We're also on YouTube at 1x Developer Podcast. You can email us if you're weird at 1xdeveloperpodcast at protonmail.com. And lastly, don't forget to follow, subscribe, all that stuff, so you don't miss any further episodes of the 1x Developer Podcast. Thanks so much. See you next time.